just looking at the space shuttle's external tank. Obviously we've got an image here. It's obviously from NASA. Just want to come down to here. When the solid rocket boosters separate at an altitude of approximately 28 miles, the orbiter, along with the main engine still burning, carries the external tank piggyback to near orbital velocity, approximately 70 miles above the Earth. The now nearly empty tank separates and falls in a pre-planned trajectory, with the majority of it disintegrating in the atmosphere and the rest falling into the ocean. Okay, but we've got that figure of 70 miles there. Above the Earth, they jettison or separate from the main tank. Okay, so we're told space starts at the Kármán line, which is 62 miles up. I'm going to zoom in on my cartoon here. You can see the Kármán line at the bottom there, 62 miles, showing the start of space. And of course, in this region, we've got space shuttles, supposedly, and space stations. And as we've just seen from the official document, the space shuttle separates at 70 miles up, so 8 miles above the Kármán line. In space, the space shuttle separates from its external tank, having got to space. Okay, so we've got that as a reference now as well. Now we're going to have a look at a short clip from NASA showing an external tank separation from one of the space shuttles. I'm just going to go down to the toolbar. I'm going to scan it back and forth. Just quickly before we do look at the clip, because I want to highlight to you the angle of the space shuttle in relation to the horizon here. You can see the angle of it is angled up a bit there in relation to, if we looking at the box at the bottom right, just before separation it levels out. It's angled all the way here and then levels out just before separation. Okay, see it's angled and then just before separation it levels out. Okay, angled, levels out. So just pay particular attention to that. I'll play the clip, it's a very short clip, play it without stopping it, and then I'll come back and then break it down with my points I'm going to make.
Eight minutes, 15 seconds into the flight, standing by for main engine cutoff. That'll be followed a few seconds later by the separation of the external fuel tank. Booster officer confirms main engine cutoff. For the last time, the space shuttle's main engines have fallen silent as the shuttle slips into the final chapter of a storied 30-year adventure. Now standing by for external tank separation.
And then we get external tank separation. The problem is, I noticed from this footage that NASA are actually relying on air resistance for their space shuttle external tank separation, but they're supposedly in space. Remember, we saw the details, they're supposedly in space at 70 miles up when this procedure takes place. The Kármán line's 62 miles, so this is in space. So why does it seem from this footage that NASA are relying on air resistance to separate their space shuttle from their external tank? There's evidence of air resistance all around here. Bearing in mind the engines have cut off. But that is why they changed the angle of attack just before separation. Because if it was pitched back and they separated, because of the air resistance, it would have blown the tank into the space shuttle. They had to level it out a bit and let the aerodynamics of the space shuttle itself come into play. And of course, the air resistance did the rest. And as a result, the air resistance, the angle of attack, is what separates this space shuttle from the external tank. But the problem is, you're supposed to be in space, not using air resistance to separate your tank from your space shuttle. So let's see this clip again.
15,000 miles.
There's the angle that will not be good for separation because of the air resistance and the angle of attack, and it will push the the external tank into the shuttle, which is why they had to level out like this and let the aerodynamics of the space shuttle, no doubt designed specifically, more than likely for this procedure, this separation, to sell the lie. But the aerodynamics and of course the air drag take care of business here and help this separation. We can even see the evidence of air drag.
Booster officer confirms main engine cutoff. For the last time, the space shuttle's main engines have fallen silent as the shuttle slips into the final chapter of a storied 30-year adventure. Now standing by for external tank separation.
Evidence of air drag all over the place. The procedure itself relies on air resistance, and the fact you changed your angle to suit that procedure, i.e. for drag. And of course the design of the shuttle takes care of business there, separating the tank will fall down, and this space shuttle goes on, no doubt, to do something else, come down somewhere else, no doubt. But of course you've got the footage there that won over 1 million hearts. But the problem is, as we've just seen looking at it, your space technology relies on air resistance. It's a bit of a boo-boo. No one's ever left Earth and gone to a place that is outside of an air pressure system that is now suddenly all vacuum. No such place exists. These rockets are going up to as high as they can, and that's it. That's as high as you go, and you can still got air there, clearly, as NASA's space shuttle and their external tank separation relied on air resistance. This is a very bad day in the space, on the space pantomime scene. Dear oh dear.